Okay, so let's talk about angle of elevation versus angle of depression. And it's basically what we would think, right? Angle of elevation means I'm elevating, going up. Angle of depression is kind of like we're going down from a certain piece. The only part is we need to make sure we know where the horizon is, right? So we kind of have to have that horizontal line, that baseline. And then if they say 20 degrees above the horizontal or an elevation of 20 degrees, we know that that means from the horizontal line we go up. That's where our theta would be. And if I'm given something like an angle of depression from a horizontal line, I have to say, okay, I'm going to go down from that horizontal line, and that would be my angle of depression. Okay, so let's look at a couple of examples. All right, so this example says if the sun is 20 degrees above the horizon, right, so that's an angle of elevation, find the length of a shadow cast by a building that is 600 feet tall. So we just kind of have to draw out what we have and then see what we can do to find the length of the shadow. Okay, so I have the sun is 20 degrees above the horizon. So here's the horizon, right? Sun is shining 20 degrees above that line. So I'm going to make sure that I'm going above my line, and we'll just assume that's 20 degrees. Find the length of a shadow cast by a building that's 600 feet tall. So here's my building. Right? It's 600 feet tall. And I want to know, here's my building, here's the shadow that it's casting down. I want to know, well, what's the length of that shadow? So I'm just going to put here, missing length is h. Now think about, why would I call that h? Well, it's the hypotenuse, right? You can label it anything, x, a, b, c, but it's just helpful if you kind of label the sides based on what you know. Okay, so I could have called it L, length of the shadow. I just chose h for hypotenuse. So now I do have a little right triangle in here. Yes, this is my building. Yes, this is my angle of elevation, but I have a nice little right triangle. I know that this is 20 degrees for my theta. I'm missing the hypotenuse, that's what I'm looking for, and I have that this length here is 600 feet. So then I look to say, well, let's use some trigonometry to figure out what this side is. I'm not asked to solve for the entire right triangle, just this length here. So I know the opposite side is 600. I'm looking for the hypotenuse, so then I go back to SOHCAHTOA and say, okay, what trig ratio uses opposite and hypotenuse? And it happens to be sine, so I'm just going to use that. Sine of theta equals opposite over hypotenuse. Okay, so I know that theta is 20 degrees, so sine of 20 degrees equals, my opposite side is 600, my hypotenuse we called h, we don't know what it is, and now I have an equation that I can use to solve for h. H is the only missing piece. I'm going to solve for h. All right, I can multiply both sides by h. So I have h times sine 20 degrees equals 600. Remember that sine 20 is one number that I'm going to plug into the calculator. I can't start moving the 20 because it's not just 20, it's sine of 20. So it's some kind of decimal of whatever sine 20 is. So my job is to get h by itself, so I'm just going to divide both sides by sine 20. And this is what I'm plugging into the calculator. 600 divided by sine 20. And because 20 is in degrees, I'm making sure my calculator, again, is in degrees. So I have 600 divided by, I'm going to put this in parentheses, sine of 20 degrees. Again, I'm just going to double check. Go to mode. My calculator is in degrees, so we're good there. So I have 600 divided by sine of 20 degrees. Hit enter. I get 1,754. 1,754.82. We'll leave it as 2 numbers after the decimal. And because we were in the units of feet, my answer should be in feet. Okay. So now I know the length of the shadow that this building cast is 1,000. Oops. 1,754.28 feet. All right, let's look at one other example. So it says here, during takeoff, an airplane's angle of climb, okay, so when you think of climb, that's angle of elevation, that's going up, is 18 degrees. Its speed is 275 feet per second. How long will it take the plane to climb to an altitude of 10,000 feet? So let's go ahead and draw the horizontal. It says, during takeoff, this plane, it's going to kind of go on the runway and take off, and its takeoff angle is 18 degrees. Go ahead and draw that in. This angle here is 18 degrees. All right, angle of climb, so it's kind of climbing up, going up 18 degrees. Its speed is 275 feet per second. So that 275 feet, it's a speed, but it does kind of tell me how to figure out the length. But what length is it? It's got to be this length. If my plane is here, and I'm a terrible artist, but let's just say this was a plane, sorry. Oh, the more details, the worse it gets. All right, let's just say that's a plane. If it's going at an angle of 18 degrees, 275 feet per second, that's this speed. That's the trail that it's taking. So this is 275 feet per second. Okay, so after 1 second, it's already traveled 275 feet, right? And then another 275 feet every second. Okay, so I can use this. This is not the length of the side, but I can use that to figure out how long the side is. All right, but our question is, how long will it take the plane to climb to an altitude of 10,000 feet? Now, altitude is just how high up from the ground the plane is, right? What's our altitude? So here would be your altitude. They're saying, how long is it going to take this length here to be 10,000? So they're really asking us to do two things. We kind of need to figure out, well, I know how high up you are, but I have to figure out this length here of the hypotenuse, right? And once I find that length, and I can say, okay, well, however many feet that is, let's figure out how many seconds it took you to get there. Okay, so let's just figure out first, I'm going to call this h again, what h is. Okay, so we have same scenario as we had above. We have a theta here. We have the opposite side is 10,000. We don't know the hypotenuse. The trig ratio that uses opposite and hypotenuse is sine, so I'm going to use that fact. That sine of theta equals opposite over hypotenuse. Alright, so sine of 18 degrees equals my opposite side over my hypotenuse, which I don't know. I'm going to multiply both sides by h. So I have h times sine 18 equals 10,000. Alright, because my h's cancel out. And then again, I can't really just move the 18 because it's not 18. It's sine of 18, so I have to move the entire thing. I'll multiply both sides by sine 18. So my hypotenuse is whatever 10,000 divided by sine 18 is. I'm going to plug that into the calculator. 10,000 divided by sine 18 degrees. I get 32,360, so let's put that in as our hypotenuse, 32,360.68 feet. Okay, which is good. That tells me how long this hypotenuse is, like how far the plane has basically gone into the air. But our question was, how long will it take for it to get to this point? All right. So when the plane is 10,000 feet high above the ground, it's actually traveled a diagonal length of 32,000 feet, 360. Okay, so our job is to figure out, well, how long did it take that to happen? That's just a simple, kind of like chemistry, change of units, right? So I know that I have 32,360.68 feet, right? And if I multiply that by, in 1 second, it can go 275 feet. So I'm basically just dividing out how many feet it's gone. How many 275 feet it's gone. So I just take my number, divide it by 275. I get 117.68. I'm going to put here time. 117.68, and because it was in seconds, I'm going to say seconds. That's not even 2 minutes. It takes the plane less than 2 minutes to go 32,000 feet, to travel 32,000 feet. Okay, so that's the end of this video. Go ahead and try some examples, and then of course email if you have questions.